we are 70% water and only 30% land. And so really, the availability of fresh water is simply about energy and transport.
Obviously, the issues we're facing are very serious, with climate change, and we're experiencing these issues on a day-to-day basis.
Tesla has long been at the forefront of battery innovation, with every vehicle relying on its advanced lithium-ion technology. The evolution of the Model Y, much like the Model 3, has seen steady improvements, most notably the introduction of Tesla's groundbreaking 4,680 cells battery. But now Elon Musk announced that he would be using aluminum-ion batteries for its 2025 Tesla Model Y. What makes this new battery so special, and will this battery be the one to replace lithium-ion technology and power the next generation of Tesla's Model Y? Tesla's next big battery leap. If you know Elon Musk, you know he's a man who loves challenging the odds. His habit of breaking barriers and presenting bold ideas sets Tesla apart from competitors like Volkswagen and GM. From revolutionizing electric vehicles to evolving solar energy, the company has consistently pushed beyond the limits of what's possible. And now, with the same spirit, Tesla is taking on a new challenge with aluminum-ion battery technology, an innovation that could change the game for energy storage, electric vehicles, and sustainable living. With this bold vision, Tesla would be the first automotive company to use an aluminum-ion battery, and it's easy to see why this breakthrough is sparking so much excitement. With the potential to charge fully in 15 minutes, aluminum-ion batteries are rewriting the rules for the future of electric vehicles. This next-generation technology has the potential to redefine how we think about powering our cars. Under Elon Musk's leadership, Tesla is once again pushing the boundaries of what's possible, exploring this cutting-edge technology to drive the next wave of innovation. But what exactly makes aluminum-ion batteries so special, and why do they hold so much potential? To start, aluminum-ion batteries bring several remarkable advantages to the table. Aluminum, the third most abundant metal on Earth, is a game-changer in terms of accessibility and cost. Unlike lithium, which requires intensive and often environmentally damaging mining practices, aluminum is easier to recycle without compromising quality. This means that these batteries are not only more affordable to produce but also far more sustainable, aligning with Tesla's vision of an eco-friendly transportation future. The backbone of this technology is a state-of-the-art material, an organic redox polymer based on phenthazine. While it sounds complex, this innovative material essentially allows aluminum-ion batteries to hold more energy than traditional designs. In fact, their storage capacity, measured at 167 mAh per gram, significantly outperforms the graphite typically used in lithium-ion batteries. This innovation opens the door to higher energy density and better performance, making aluminum-ion batteries a strong contender to replace lithium-ion technology. Not only this, but the aluminum-ion batteries have the potential to achieve an energy density of 1,600 watt-hours per kilogram. To put that into perspective, today's lithium-ion batteries typically cap out at around 450 watt-hours per kilogram. This means that aluminum-ion batteries could store over twice as much energy without increasing the size or weight of the battery pack. For EVs, this translates into a significantly extended range, potentially up to 2,000 miles on a single charge. Imagine driving across the country without worrying about running out of power. That's the promise this technology holds. But it's not just about how far you can go, it's also about how quickly you can get back on the road. Aluminum-ion batteries are designed to fully charge in just 15 minutes, as we said previously, a dramatic improvement over the 30 to 45 minutes required by most lithium-ion batteries to reach 80%. This kind of rapid charging could transform charging stations into quick pit stops, making EVs as convenient to recharge as filling up a traditional gasoline tank. Durability is another standout feature of aluminum-ion technology. These batteries are built to last, retaining 88% of their capacity after 5,000 charge cycles. Under optimal conditions, they can support up to 15,000 cycles, giving them a potential lifespan of 20 years or more. This durability not only reduces the need for replacements but also makes EV ownership more cost-effective and sustainable. But what about Tesla's current lithium-ion technology? What challenges are pushing the company to explore this new frontier, and can aluminum-ion batteries truly deliver on their promise to revolutionize EVs? To understand the driving force behind Tesla's shift, we need to take a closer look at the limitations of the 4680 battery and the opportunities that aluminum-ion technology presents. Why lithium battery can't keep up? Tesla's 4680 battery has been a major milestone in the evolution of electric vehicle technology, offering significant improvements over its predecessors. With its innovative tablet design and advanced chemical composition, the 4680 battery has brought new levels of efficiency, power, and integration to Tesla's lineup. It powers vehicles like the Model Y, delivering a range of approximately 330 miles on a single charge and charging to 80% in around 30 minutes using a supercharger. Yet despite these advancements, the limitations of lithium-ion technology remain, and these constraints highlight the growing need for alternative solutions. One of the most prominent challenges lies in the energy density of lithium-ion batteries. The 4680 cells battery, with a density of around 255 to 280 watt-hours per kilogram, represents a significant leap forward compared to earlier designs. However, this still restricts how far an electric vehicle can travel on a single charge. While Tesla has optimized the use of this energy to extend range, it is clear that lithium-ion technology is nearing its ceiling, making it harder to push boundaries without exploring entirely new materials and designs. Charging speed is another area where lithium-ion technology shows its limitations. Although the 4680 battery can reach 80% charge in 30 to 45 minutes, this is still a far cry from the convenience of refueling a gasoline vehicle. For drivers looking for quick and efficient pit stops, this can feel like a compromise, especially when electric vehicles are marketed as the future of transportation. Faster charging remains a crucial goal to make EVs more accessible and practical for a wider audience. We can't ignore the safety concerns here. These batteries rely on a flammable liquid electrolyte, which, in the event of physical damage or internal faults, can lead to thermal runaway. This phenomenon, where overheating causes a chain reaction that can result in fires or explosions, is a significant risk that EV manufacturers must address. Tesla's cooling systems mitigate this danger, but these systems occupy valuable space within the vehicle, space that could otherwise be utilized for more energy storage or additional passenger comfort. The reliance on such complex safety mechanisms underscores the inherent risks of lithium-ion batteries. Beyond performance and safety, environmental and economic challenges further complicate the widespread use of lithium-ion batteries. The materials used in their construction, such as lithium and cobalt, are not only expensive but also difficult to recycle. These components often require resource-intensive processes to recover, making recycling costly and environmentally taxing. Structural integration is one of the standout innovations of the 4680 battery, where the battery pack itself becomes a part of the vehicle's chassis. This design enhances rigidity, reduces weight, and optimizes interior space, marking a significant improvement in vehicle efficiency. However, this innovation does not eliminate the fundamental reliance on lithium and cobalt, materials that remain costly and environmentally problematic. While the structural integration of the 4680 battery has undoubtedly pushed the boundaries of what lithium-ion technology can achieve, it also highlights the limitations that come with it. These challenges point to a pressing question: is lithium-ion technology enough to sustain the rapid advancements needed in the electric vehicle industry? Addressing these limitations requires looking beyond lithium-ion technology altogether, and that's where aluminum-ion batteries come into the conversation. But along with this, there comes another question. Can aluminum-ion batteries overcome these limitations and redefine the future of electric vehicles? The battery that breaks limits. Building on this momentum, Tesla's shift toward aluminum-ion batteries isn't just an incremental upgrade, it's a bold step toward addressing the fundamental challenges of lithium-ion technology. These batteries promise to redefine the electric vehicle experience, tackling everything from charging speed to safety and sustainability. So how exactly do aluminum batteries aim to overcome the limitations of their lithium-ion predecessors? Let's start with one of the most revolutionary aspects: charging speed. Picking up from an earlier point, aluminum-ion batteries promise to fully charge in just 15 minutes, a feat that makes them 20 times faster than current lithium-ion batteries. Imagine pulling into a charging station, plugging in your car, and being back on the road before you've even finished your coffee. For drivers who've grown accustomed to the slower charging times of lithium-ion systems, this change transforms EV ownership into something far more convenient and practical. It's a leap that could make charging your EV feel as seamless as refueling a gasoline car, eliminating one of the last hurdles holding back widespread adoption. Speed, however, is only part of the story. Aluminum-ion batteries also boast an impressive energy density of up to 1,000 watt-hours per kg, a significant improvement over the 4,680 batteries maximum of 280 watt-hours per kilogram. This leap in energy density means that vehicles equipped with aluminum-ion batteries could achieve ranges of up to 2,000 miles on a single charge, an astonishing figure that makes even the most ambitious lithium-ion systems look outdated. For drivers, this translates into fewer charging stops and the freedom to take long road trips without the constant worry of running out of power. Durability is another area where aluminum-ion batteries excel. These batteries can support up to 15,000 charge cycles with proper management, significantly outlasting the lifespan of lithium-ion batteries. To put that into perspective, a car powered by an aluminum-ion battery could remain operational for over 20 years without requiring a battery replacement. This longevity not only reduces costs for drivers but also minimizes the environmental impact of producing and disposing of battery materials. It's a win-win that aligns perfectly with Tesla's commitment to sustainability. Previously, we touched on the safety concerns surrounding lithium-ion batteries due to their flammability. Aluminum-ion batteries address this issue with their non-flammable design and exceptional stress tolerance. This makes them far less prone to the overheating and thermal runaway issues that have plagued lithium-ion systems. And the standout feature of aluminum-ion batteries lies in their sustainability, perfectly aligning with Elon Musk's vision of creating a greener, more sustainable future. Aluminum is one of the most abundant elements on Earth, making it a far more accessible and cost-effective resource than lithium. Its abundance not only reduces production costs but also alleviates the geopolitical and environmental challenges associated with mining rare materials like cobalt and lithium. Additionally, aluminum is highly recyclable, ensuring that these batteries align with Tesla's mission of creating environmentally responsible solutions. By shifting to aluminum-ion technology, Tesla isn't just making EVs more efficient, it's making them sustainable. It's worth noting how aluminum-ion batteries connect back to some of the challenges posed by lithium-ion systems. While the advantages of aluminum-ion batteries are clear, of course no technology is perfect, and aluminum-ion batteries do have their challenges. The promise of faster charging, greater range, and improved sustainability is exciting, but it also raises questions about the technical hurdles that remain. Can aluminum-ion batteries achieve the high voltage required for demanding EV applications? How Tesla plans to tackle them? Can this promising technology truly live up to its potential? Aluminum-ion's toughest roadblocks. While aluminum-ion batteries promise to revolutionize the EV industry with their speed, safety, and sustainability, the challenges are also real. A key challenge that stands out is the voltage limitation of aluminum-ion batteries. Currently, these batteries generate only about half the voltage of their lithium-ion counterparts. Voltage is a critical factor for powering EVs as it directly impacts the battery's ability to meet the high demands of electric motors. While aluminum-ion technology excels in energy density, its lower voltage output means it struggles to deliver the same level of performance required for today's electric vehicles. This limitation underscores the need for further research and development to bring aluminum-ion batteries up to the standards of commercial EV applications. Beyond just voltage limitations, there are technical hurdles to overcome, particularly in the design of the battery's internal components. The use of advanced materials such as nanostructured cathodes is essential for improving the efficiency and performance of aluminum-ion batteries. These cathodes allow for better energy storage and faster charging while minimizing the degradation that occurs over time. However, developing these materials at scale is a complex and costly process. Researchers are actively exploring ways to refine the technology, but significant investments in material science and engineering are still needed. Scaling production is another significant challenge. While aluminum-ion batteries hold great promise, their manufacturing processes are far more intricate than those of lithium-ion systems. For instance, the production of nanostructured cathodes and advanced electrolytes requires highly precise techniques that are not yet widely available. Tesla's ability to meet its ambitious production targets for vehicles like the Model Y will depend on whether these processes can be streamlined and scaled efficiently. Without this scalability, the cost of aluminum-ion batteries could remain prohibitively high, slowing their adoption in the EV market. On top of that, the potential success of aluminum-ion batteries is closely tied to the strength of their supply chain. While aluminum is abundant and cost-effective, transitioning to a new material base involves reconfiguring existing supply chains and manufacturing infrastructure. Tesla will need to ensure that its suppliers can meet the quality and sustainability standards required for aluminum-ion production. At the same time, The company must navigate potential bottlenecks in securing advanced materials like organic redox polymers and nanostructured components. Despite these challenges, there are reasons to remain optimistic. Tesla has a history of tackling complex problems and delivering innovative solutions, as evidenced by the success of its 4680 battery. The lessons learned from overcoming the limitations of lithium-ion technology could serve as a foundation for addressing the issues with aluminum-ion batteries. For instance, Tesla's dry electrode manufacturing process developed for the 4680 may provide insights into how to streamline the production of aluminum-ion batteries. It's also worth noting that many of these challenges are not unique to aluminum-ion batteries. Voltage scalability and supply chain issues have all been hurdles in the development of previous battery technologies, including lithium-ion systems. The fact that lithium-ion batteries evolved to meet the demands of modern EVs suggests that aluminum-ion technology could follow a similar trajectory with the right investments in research and infrastructure. Taking stock of what aluminum-ion batteries offer, it's clear that the potential rewards justify the effort. These batteries offer a combination of features: faster charging, longer lifespan, and greater sustainability that address many of the shortcomings of lithium-ion technology. For Tesla, overcoming the challenges of aluminum-ion batteries isn't just about improving performance, it's about leading the way of sustainable transportation and solidifying its leadership in the EV market. As Tesla continues to refine this technology, the stakes couldn't be higher. Aluminum-ion batteries represent not only a leap forward for Tesla, but also a potential game-changer for the entire EV industry. They have the power to set a new standard for what electric vehicles can achieve, from extended range to faster charging and beyond. However, before they can fulfill this promise, these challenges must be met with innovation, collaboration, and determination despite these obstacles. The next chapter, the potential impact of aluminum-ion batteries on the EV industry, is monumental. If Tesla can successfully address these challenges, this technology could redefine electric vehicles, making them more efficient, affordable, and accessible than ever before. The last thing that needs justification is how aluminum-ion batteries could revolutionize the 2025 Model Y and transform the EV market as a whole. Could this be the breakthrough that propels electric vehicles into a new era of dominance, the next chapter in EVs? The potential impact of aluminum-ion batteries on Tesla's 2025 Model Y is nothing short of transformative. With groundbreaking features like extended range, faster charging, and unmatched longevity, these batteries promise to redefine the electric vehicle experience and set a new standard for the industry. But what makes this innovation so revolutionary, and how will it redefine the future of EVs? To better understand this, imagine driving an electric vehicle covering up to 2,000 miles on a single charge. That's the kind of range aluminum-ion batteries could offer, dwarfing the current capabilities of lithium-ion systems, which typically top out around 330 miles per charge in Tesla's Model Y. This improvement in energy density, up to 1,000 watt-hours per kilogram, represents a leap forward in battery technology. For drivers, it means fewer stops on long journeys and the freedom to travel vast distances without constantly planning for charging stations. It's a solution that directly addresses one of the most common concerns for EV owners: range anxiety. Charging speed is another area where aluminum-ion batteries stand out. These batteries can fully charge in just 15 minutes, a fraction of the time required by current lithium-ion systems, which take 30 to 45 minutes to reach 80% capacity using Tesla's superchargers. This rapid charging capability could make EVs as convenient as refueling a gasoline car, eliminating one of the last perceived disadvantages of electric vehicles. For busy drivers and families on the go, this efficiency could be a game-changer, making electric vehicles an even more appealing choice. But aluminum-ion batteries don't just offer more range and faster charging. They also last longer, with the ability to support up to 15,000 charge cycles. These batteries could virtually eliminate the need for replacement over a vehicle's lifetime. This durability not only makes aluminum-ion batteries more cost-effective, but also reduces waste, aligning perfectly with Tesla's commitment to sustainability. The broader implications of this technology extend far beyond individual vehicles. By integrating aluminum-ion batteries into the 2025 Model Y, Tesla sets a new benchmark for the entire EV industry. Competitors like Rivian and Lucid Motors, and traditional automakers such as Ford and General Motors, will feel the pressure to innovate or risk being left behind. Aluminum-ion batteries offer a combination of features that competitors simply cannot match with existing lithium-ion systems. forcing the industry to accelerate its adoption of advanced energy storage solutions. Beyond their impact on vehicles, aluminum-ion batteries also have the potential to revolutionize how we think about energy storage. With enhanced compatibility with renewable energy grids and vehicle-to-grid applications, these batteries could turn EVs into mobile energy hubs. It is just like using your car to store excess solar energy during the day and then feeding that energy back into the grid or your home at night. This capability not only maximizes the utility of renewable energy but also reduces reliance on fossil fuels, contributing to a cleaner and more efficient energy ecosystem. For Tesla, this innovation represents more than just a technological breakthrough. It's a strategic move that reinforces the company's leadership in the EV market. By adopting aluminum-ion batteries, Tesla demonstrates its commitment to pushing the boundaries of what electric vehicles can achieve. This move solidifies Tesla's reputation as an innovator and a pioneer in sustainable transportation, setting it apart from competitors and inspiring confidence among consumers and investors alike. Moreover, the adoption of aluminum-ion batteries could drive EV adoption on a much larger scale by eliminating range anxiety, reducing charging times, and lowering long-term costs. These batteries make electric vehicles more accessible and practical for a wider audience. For many potential buyers, these advancements address the key concerns that have traditionally held them back from making the switch to electric. As more drivers experience the benefits of aluminum-ion technology, the momentum toward a fully electric future could accelerate rapidly. It's worth noting how these revolutionary features build upon the lessons learned from previous innovations. For example, the structural integration of the 4680 battery demonstrated the importance of optimizing space and weight in vehicle design. Aluminum-ion batteries take this principle even further by offering greater energy density without increasing battery size, allowing for more efficient and versatile vehicle configurations. Similarly, the emphasis on sustainability reflects Tesla's broader mission, ensuring that technological progress is accompanied by environmental responsibility. Despite the challenges aluminum-ion batteries face in terms of scalability and development, their potential to change the EV industry is undeniable. These batteries promise to transform not only the 2025 Model Y but also the broader energy ecosystem, making electric vehicles more efficient, sustainable, and user-friendly than ever before. As Tesla continues to refine this technology and prepare for its integration, one thing is clear: aluminum-ion batteries have the power to propel the EV industry into a new era. The only thing left is how quickly these advancements can be brought to market and how they will influence the choices of other automakers. Tesla's aluminum-ion battery has the potential to revolutionize electric vehicles with its speed, range, and sustainability, but with challenges like voltage limitations and production hurdles, the road ahead isn't without its obstacles. The sleeping giant awakens. Toyota has been a key player in the car industry since the early 1900s. Back in the year 1933, the company was just starting to dip its toes into automobiles, shifting from textile machinery to car manufacturing. The first big move came in the year 1936 when they rolled out the Model A sedan that kicked off decades of reliable, practical, and affordable cars, exactly what made Toyota a household name. Then came the Corolla in the year 1966, and Toyota cemented itself as the go-to brand for dependable transportation. But little did the world know Toyota was about to make a decision that would change the course of automotive history. Was forever changed by Toyota on one side and Elon Musk on the other. Toyota's story began early, transitioning from textile machinery to car manufacturing in the 1930s, with milestones like the Model A sedan in 1936 and the Corolla in 1966, cementing its reputation for dependable, affordable cars. Meanwhile, Elon Musk's journey started not with cars but technology. In the 1990s he built Zip2, followed by PayPal, revolutionizing online finance. In the early 2000s, Musk focused on Tesla, aiming to make electric cars not just practical but desirable. The early Tesla Roadster proved the concept, and the Model S in 2012 changed everything, showing electric cars could be powerful, stylish, and profitable. Toyota took a different path by perfecting hybrids, introducing the Prius in 1997, a game-changer that combined a gas engine with an electric motor, cutting fuel consumption dramatically and making hybrid cars affordable and popular. While Toyota refined hybrids, Tesla pushed full electric. The Model S proved electric cars could be luxury vehicles, boasting range, speed, and technology that turned heads. Tesla's charging network expanded, and EVs shifted from niche products to serious competitors against gas-powered cars. Other automakers like Ford, General Motors, and Volkswagen entered the electric market, but challenges emerged. Charging infrastructure lagged, causing range anxiety, and charging times were much longer than refueling gas cars. For those without home chargers, switching to electric was impractical. Despite incentives, EVs remained costly due to expensive batteries and rising raw material prices. Toyota kept improving hybrids, making them cheaper, more reliable, and efficient. Now, Toyota is developing a next-generation engine combining efficiency, sustainability, and convenience without relying solely on electric power. This could make hybrids dominant again and pressure full electric cars. If successful, Toyota might prove EVs aren't the ultimate solution. Tesla, meanwhile, faces more competition as traditional automakers catch up, shrinking Tesla's unique edge. If Toyota's technology succeeds, the EV market could be shaken. But a major issue remains rarely discussed: the environmental and practical problems of EV batteries. EVs are marketed as greener, cleaner alternatives to gas cars, but battery production and disposal pose serious problems. Mining for lithium and cobalt damages environments and involves poor labor conditions. Recycling batteries is inefficient, and waste could pile up in landfills, creating new environmental hazards. These realities cast doubt on the green label of EVs. The money problem is real too. EV prices have dropped but remain higher than traditional cars, mainly due to battery costs and expensive materials. High interest rates and economic uncertainty make buyers cautious, and many see gas cars as a more affordable choice. Government incentives that helped early EV adoption are fading globally, reducing buyers' motivation to switch. This cooling off is worldwide. Tesla's U.S. market share dropped from nearly 80% of EV sales to less than half. In China, Tesla lost ground to local brands like BYD, and in Europe, sales fell sharply as Volkswagen and Toyota gained. People are reconsidering EVs, and Tesla's dominance is challenged. Tesla's revenue growth has stalled, with little improvement expected, causing analysts and investors concern. Elon Musk faces mounting pressure amid recent controversies. The EV industry is hitting roadblocks. Charging networks aren't adequate, battery production is problematic, and prices remain high. So, if EVs aren't perfect, what's next? Toyota stands out. While Tesla and others focus on pure electric vehicles, Toyota invests broadly in hybrids, plug-in hybrids, hydrogen fuel cells, and battery EVs. Rumors suggest Toyota may be developing something revolutionary. Known for reliability and practicality, Toyota's gasoline and diesel engines have powered durable vehicles. The hybrid revolution started with the Prius, and Toyota even explored hydrogen fuel cells with the Mirai, which emits only water vapor. Though hydrogen hasn't taken off widely, Toyota's commitment to alternative tech is clear. Tesla took a different route: no hybrids, no fuel cells, only pure electric. Tesla's motor tech has been groundbreaking. The Model S Plaid offers extreme acceleration and efficiency. Tesla also pushes battery innovation, aiming for batteries lasting 1 million miles to extend vehicle life and reduce recycling needs. They manufacture batteries in-house to avoid supply chain issues. No doubt, Tesla has been leading the charge in electric propulsion, but Toyota is playing a longer game. While Tesla was all in on electric vehicles, Toyota stayed cautious, investing in multiple options instead of betting it all on one. That strategy might finally be paying off. If battery electric vehicles are losing steam, Toyota has something else up its sleeve, and that is where the real twist comes in. Some insiders say Toyota has been working on an engine that could change everything people think they know about cars, a new kind of hydrogen-based system, but way different from the fuel cell technology seen before. Supposedly, this thing can extract hydrogen from water directly inside the vehicle, meaning no need for an extensive hydrogen fueling network. If that is true, this could be a game-changer: cleaner than batteries, easier to refuel than electric cars, and possibly much cheaper to produce in the long run. Rumors say the engine works by using an advanced catalyst that makes the hydrogen extraction process super efficient. No heavy, expensive batteries needed, no waiting hours to charge, and no massive environmental impact from mining rare materials. If Toyota really has cracked this technology, they might just leap ahead of the electric vehicle industry and introduce something even better. Even Elon Musk, the biggest advocate for electric vehicles, is rumored to be paying attention. If the man who built Tesla into an empire is reconsidering his stance, that says a lot. Whether Toyota actually brings this to market soon or not, one thing is clear: the race for the future of transportation is not as settled as many thought. While Toyota and Tesla battle it out, another giant is quietly taking control, and it's happening faster than anyone expected: the rise of Build Your Dreams. Over in China, the biggest electric vehicle market on the planet, Tesla's grip is slipping. Local automakers are coming in strong, and there is a brutal price war shaking things up. If Tesla had not slashed prices by a whopping 20 to 30%, its sales would have taken a real nosedive. There is one company in particular making life tough for Tesla. Build Your Dreams is turning into Tesla's worst nightmare. In 2023, Build Your Dreams registered nearly 2.5 million new cars in China, putting them at number one with an 11% market share. This kind of growth is unheard of. Month after month, Build Your Dreams is topping the charts. The numbers do not lie. Over 3 million new energy vehicles rolled out of their factories last year, leaving Tesla's 1,800,000 in the dust. Build Your Dreams is not just winning, it is way ahead in China. Early on, Elon Musk brushed off Build Your Dreams as just another startup, but those times are long gone. Chinese automakers are no joke anymore. Once foreign brands ran the show in China, now Chinese brands own the game. Their cars are not just cheap, they are actually good. Build Your Dreams is not stopping in China, they are setting their sights on the rest of the world. Last year, their exports shot up over 300%, hitting nearly 250,000 cars across 70 countries. Build Your Dreams already owns about 40% of the Chinese electric vehicle market and is making moves into Australia, Japan, Europe, and even knocking on the door of the United States. Analysts predict Build Your Dreams could break into the global top 5 automakers by 2026. This year, they are already on track to hit the top 10. Build Your Dreams started way back in 1995, not as a car maker, but as a battery company. Wang Chuanfu, the founder, set up shop in Shenzhen, China. For the first decade, it was all about low costs. They churned out batteries for big names like Motorola and Nokia, undercutting competitors left and right. Then in 2003, they made a bold move into the car business by buying a struggling automaker. Their first car, the F3, hit the market in 2005. It was a gas-powered knockoff of the Toyota Corolla. By 2008, they launched the F3DM, a plug-in hybrid, but it was not exactly a game-changer. Early Build Your Dreams cars were cheap, clunky, and forgettable. They finally went fully electric in 2010 with the E6. Taxis loved it because they got incentives, but regular folks were not biting. Through most of the 2010s, Build Your Dreams auto division was stuck in slow gear. Sales were growing but not by much. By 2018, things were looking rough. Sales were even dropping year over year. But then something clicked around 2019. Build Your Dreams started cranking out better-looking cars. Models like the Tang and Han, designed by top German designers, finally had some style. In 2022, they dropped gas-powered cars altogether, focusing only on hybrids and electric vehicles. That shift changed everything. Build Your Dreams got a big boost from Warren Buffett's Berkshire Hathaway, which invested in them way back in 2008. Buffett admitted he did not get the whole electric vehicle thing but believed in Wang Chuanfu. That bet paid off big time. Build Your Dreams stock has skyrocketed more than 1,400% since Buffett first got in. But even Buffett has been cashing out, selling off more than 60% of his stake since last summer. Some say it is geopolitics. Others say it is the electric vehicle price war Tesla started. Either way, Build Your Dreams is still standing strong. Build Your Dreams' ace up its sleeve is price. They are undercutting everyone. Take the Seagull, launched in Munich last year, with a price tag of $11,500. That is way below anything Tesla offers. Most of Build Your Dreams cars are in the affordable range, hitting the sweet spot where the real volume is. Another big win is batteries. That is the most expensive part of an electric vehicle, and Build Your Dreams owns the whole process. They do not just make their own batteries. They sell them to other car makers too, including Tesla, Toyota, and Kia. Their Blade battery, launched in 2020, is a game changer. It is a lithium iron phosphate battery that is safer, cheaper, lasts longer, and has gotten the whole industry's attention. Build Your Dreams is not just making passenger cars. They also have electric buses and trucks and even build electric buses in California. But passenger cars are where the real money is, and Build Your Dreams is going all in. Their lineup has something for everyone. The Dynasty series has budget-friendly options like the Qin at $14,000 and the high-end Tang at $34,000. The Ocean series is aimed at younger buyers with the tiny Seagull at $10,000 and the Seal sedan at $22,000. They have also stepped into the luxury game with brands like Denza, Yongwang, and Fengchong Bao. They are not just making cheap cars anymore. They are making supercars and sport utility vehicles that can go head-to-head with the best in the business. Outside China, Build Your Dreams is already dominating Southeast Asia. They own 43% of the electric vehicle market there and are number one in Thailand, Brazil, Colombia, and Israel. In Thailand alone, they went from 0 to number 1 in just a year. If tariffs drop, would you drive a Build Your Dreams, or is brand loyalty worth the extra cash? Drop a comment, like, subscribe, and hit the bell. Catch you next time.